Hi students, welcome to my channel Mastering Physics and Math. In this video, I will solve the first two questions in this paper, Physics, Paper 3 Extended, May-June 2015. First question. A. Figures 1.1 and 1.2 show speed time graphs for two objects, each moving in a straight line. I. Describe the motion of the object shown by the graph in figure 1.1. This graph here is a straight line. So the gradient of the line is constant, and the gradient is the average of speed with respect to time, the time rate of increasing speed with respect to the time, which is equal to the acceleration. So acceleration here is constant. Now in this graph, the line is curved. So the gradient is changing from instant to instant. So at the beginning, at this time, I draw a tangent to the curve at this point. And at a later time, at this point, I draw another tangent. Now it is clear that the slope of this tangent is greater than the slope of this tangent. So the acceleration here is decreasing. Speed itself is increasing, but the rate of increasing of speed with respect to time is decreasing, so acceleration is decreasing. B. On a day with no wind, a large object is dropped from a tall building. The object experiences air resistance during its fall to the ground. State and explain in terms of the forces acting how the acceleration of the object varies during its fall. There are two forces acting on the object. Its weight down and the air resistance against its weight up. Now the air resistance at the start is 0, and it begins to grow and increase as the speed of the object increases, because the air resistance is directly proportional to the speed of the object. So the resultant force decreases. Resultant force equals the difference between the weight and the air resistance. And as the air resistance increases, the resultant force decreases and the acceleration decreases. This situation continues until the air resistance equals the weight, and the resultant becomes 0, and the speed of the object remains constant. This speed is called the terminal velocity. So acceleration decreases. Question 2. A large stone block is to be part of a harbor wall. The block is supported beneath the surface of the sea by a cable from a crane. Figure 2.1 shows the block with its top face a distance h beneath the surface of the sea. The force acting downwards on the top face of the block due to the atmosphere and the depth h of water is 3.5 times 10 to 4 Newton. A. The top face of the block has an area of 0.25 meters squared. I. calculate the pressure on the top face of the block. Pressure is defined to be the force over the area. Equals 14 times 10 to 4 Newton per meter squared equals 1.4 times 10 to 5 Pascal. Double I, the atmospheric pressure is 1.0 times 10 to 5 Pascal. Calculate the pressure on the top face of the block due to the depth h of water. Now the total pressure, P total, equals P atmosphere plus P of water. Now subtracting this number from both sides, we get B water equals 1.4 times 10 to 5 minus 1.0 times 10 to 5 equals 0.4 equals 4.0 times 10 to 4 Pascal. Triple I, the density of sea water is 1020 kilogram per meter cube. Calculate the depth H. Now, pressure of a liquid, water here, equals rho G H. Rho is the density, G is the acceleration of gravity, and H is the depth. Thousand and 20 times 10 is 10,200. Now using the calculator, 4 times 10 to power 4 over 10,200 equals 3.92 meter, but to two significant figures is 3.9 meter. B. Suggest two reasons why the tension force in the cable is not 3.5 times 10 to 4 newtons. The first reason is that the weight of the block and the weight of the cable The second reason is the floating force, according to Archimedes' principle. Any immersed object in a liquid suffers from a force pushing the objects up. So the second reason is the floating force due to water. C. The block is lowered so that it rests on the seabed. State what happens to the tension force in the cable. It becomes zero. Thank you very much for watching, and please follow me for the coming questions. Please like and share, and bye-bye.